So again, remember, you can't just look up the K because it's not 25. So we've got our ICE chart right here. This is 0.400. I don't have any of that or that. Minus x, x, x. 0.400 minus x, x, and x. Don't forget your K expression. Again, I always say this like because I'm writing these out. But it's always a good idea, especially when you haven't done it in a while. I like always recommend call it Ka and write out the expression first. HCN. So now we know percent ionization. So one of these x's, if I turn that percent into a decimal by dividing by 100, I get that number. And then that times my 0.400, that's my x. That's the percent ionization. So 0.078 times 0.4. So that term right there is 0.0312. Now, you can either do 100 minus this number. So that's going to be 92.2. And then do 0.922 times your 0.400. So you can either do that, or you can just go ahead and plug this in and do 0.400 minus that. Either way will work, whichever one you have a preference for. I'm going to do it this other way this time. So 0.400 minus, and then I'm just going to find that value. So that tells me what that one is. And part of the reason I'm doing that too is just to get in my calculator. So that number is 0.3688. That's that whole term. So when I go over here, this is going to be 0.0312. That's what you get from the 0.78 times your initial. There's two of them. Like it would go in as x squared, by the way. Let me scooch this down so I'm not skipping too many steps. Ka equals x squared over, it's 0.4 minus x. But I have what that whole term is because I just subtracted. So that whole term is that 0.3688. So I'm just going to say this number squared divided by, and I'm tapping the other number, gives me 2.6 times 10 to the 1, 2, 3, negative third. And like I said, you can do this with your hand calculator. You just need to make sure that you're using those arrow keys. So you can jump up to and you can like move around in the equations, or you can also save numbers by using that STO function. Sometimes I'll just like use my most current STO as whatever I just solve for in the equation. So that you can also do it that way also. Again, I would just want to note out a solution that has that high of an ionization is not so much of a strong acid. Like, again, I would expect a strong acid to be like much more negative, 4, 5, 6, 7, 8, 9 negatives on all those, 10 to the negatives. But that's fine for this one. Maybe it's at some crazy, insanely cold temperature, or high temperature. Maybe it's just at some temperature at which it acts kind of weird.